Welcome to the class, dear students. In today's lecture, I am going to explain you about the multiple integrals. So we have done with the single integrals how to solve the single integral by so many methods. And now these multiple integrals, in this especially we are discussing about the double integrals. So what is, whenever a function is defined in two or even sometimes it is three variables, then the function f of x comma y is defined on a rectangular region, suppose. Then it is given by x comma y, where x lies between a and b and y lies between c and d. Then the double integral of the function f of x comma y over that region is denoted by this one, double integral of f of x comma y dx dy over the region R, or you can say that the region R boundaries are what? X is from A to B and Y is from C to D. For example, if I have drawn the x-axis and the y-axis, suppose the values of A to B, X is from A to B and Y is from C to D. So this is what the region, this is called as the rectangular region, where X is from A to B and Y is from C to D. In this region, the function f of x is being defined. Then we define the function f of x, the double integral of that function, as like this. So that is double integral. What are the limits of y is from C to D, x is from A to B. So this is what the definition of the double integral. Now the properties, what are the properties? That is, suppose if you take double integral k times of f of x comma y dx dy is k times of double integral f of x comma y dx dy. That is how we have done in the single integral. We will take the constant outside. The same way we will take the constant outside and do the integration. And similarly for single integral, what is the sum or difference between the two functions, how we will do? We will define the integral and then plus or minus the integral of the second function. So the same rule will be applicable even the double integral. And suppose R is the union of two non-overlapping regions, R1 and R2, let us say. Then we will write that in the region R1, the double integral plus the value of the double integral over the region R2. So like that we will define the double integrals, and these are the properties. Okay. Now let us come to see the how to evaluation part of this double integrals. Let us now see this. So evaluation of the double integral. Now this is with the constant limits and the variance limits. These are the two things are there now. The evaluation part, evaluating the double integrals, with the constant limits is one part, with the constant limits is there, and with the variable limits also we will do. But now in the present class I am going to do with the constant limits. Okay. So what are the constant limits? As I told you, now in the region, on the x and y axis, suppose if it is from A to B, x is from A to B we have defined, and y is from, let us say, C to D, suppose. Then the region what we define is A to B, let us say like this, and C to D is this. So now this is the region. In this region R, we define means the limits are the constant limits. When the limits are the constant limits, the region is a rectangular region. That is what you can understand. The total region will be rectangular when the limits are like this. X is from A to B and Y is from C to D. Then this is what the constant limits means. Variable limits means when you define a function x comma, when your functions are two functions are being defined, let us say there is a straight line, let us say, and there is a parabola, let us say that y is equal to x square, parabola is there, suppose y is equal to x square and this is y is equal to x. Now we wanted to see the region between these two limits, let us say, these two curves, let us say. So in this region you wanted to find out the limit suppose, then those limits, that is not a rectangular region, right? This particular portion is not a rectangular portion, it is a curved portion. So where we define the limits by using the variables. So those variable limits that will come in the next topic. At that time I'll tell you. Just I will explain you about only the limits here. So the limits of x is from 0 to, let us say both of them are intersecting at the point 0 comma 1, let us say. So x is from 0 to 1. Then if I say y is also from 0 to 1, that becomes the rectangular region. So what we take is y is from the parabola to the straight line. So y is equal to x square to the straight line x. So this is called as the variable limits. So the double integrals we are solving by using constant limits like this, and variable limits means like this. So when the region is a curved region like this, then we use the variable limits. So this is what the difference. Now I am dealing with constant limits now at present case. So how to solve, coming to the evaluation part, how to do it. Now before going to do the problems, just I'll give you one small hint about the functions f of x comma y dx dy is there suppose. Then what you write, and the limits of x is from a to b and the limits of y are from c to d. Now observe here that it is we are first integrating with respect to x, the innermost, whatever the innermost. So this x is there. Now the limits are a to b means you have to understand that these are the limits of x. Okay, and when you say dy on the last, the outermost is y is from c to d. Even though we don't give y values, you should understand that the outermost is for y, innermost is for x. So x limits are a to b, y's limits are c to d. So the same way if I change the limits and write down, suppose it is equal to f of x comma y, I want to write this as dy dx, let us say. Then what are the limits of y you have to write here, that is from c to d, and x is from a to b. I hope you are able to understand. Now if I write this as just like this only, as c to d and a to b, which is f of x comma y dx dy, if you write, then this is wrong. Why? Because x limits are not from a to b. X limits are not from c to d. X limits are from a to b and y limits are from a to b. So that is why this is what the way you have to write is, whenever you are writing dx and dy, suppose what are these limits are x from a to b and y limits are from c to d. You can write like this. Is that clear? And now let us go to do the evaluation part, how to solve this integrals. So what we do here is, just I'll give you an example and then we'll start the problems. So let us check now this first problem, that is double integral, let us say 0 to 3 and 0 to 2 4 minus y square dy dx is there. So what we do now, first thing is always we put a bracket. Where we will put a bracket? Where that is given by, let us put the bracket in the innermost, that means this one. So now you will understand that the limits of y are from 0 to 2. So now what will you solve with this one? Integral 0 to 3. Now solve the integral with respect to y. So that means what is 4 outside and 4 dy is 4y. Integral y square becomes y cube by 3 within the limits 0 to 2 dx outside. Okay. So now let us apply the limits here first. Integral 0 to 3, outermost integral will be as it is. Now apply the limits here. 4 times of upper limit is 2, lower limit is 0. 2 minus 0 minus upper limit is 2 cube by 3, minus means you put a bracket here always, minus 0. The 0 cube means 0 and dx. So what it gives you now, that is integral 0 to 3, 4 times of 2 is 8, minus 2 cube by 3 means 8 by 3 dx. So it is 24 minus 8, which is 16 by 3 times of integral dx. What is integral dx is x within the limits 0 to 3. So the value, again apply the limits as 16 by 3 times of upper limit minus the lower limit, that is 16 by 3 times of 3, which is equal to 16. So this is the solution of this double integral. I hope you could understand. So now this is what the way of doing the problems. Innermost integral, put the limits and then put the brackets and then solve it. Let us now do one more problem on this. Let us take the problem as double integral 1 to 2, double integral 0 to 3. It is 1 plus 8x dx dy. So what we do first with respect to x, first we have to do. So what we do, we put a bracket, that is what for innermost. Then you will understand easily. So we are slowly making the double integral as single integral and solving. Now integral 1 dx is x. Integral 8x means 8x square by 2. Now put the limits from 0 to 3 dy. Okay. Now it is integral 1 to 2. Now what are now 2 1s and 2 4s gets cancelled, right? So let us now apply the upper limit is 3 for x. The upper limit is 3, lower limit is 0. Plus 4 times of the upper limit is 3 square minus lower limit, which is dy. And now what is this giving you? Integral 1 to 2. 3 minus 0 is 3 plus 9 4s are 36, correct? 3 plus 36 times of dy. Now what is 36 plus 3? 39. Integral dy is what? Y from 1 to 2. So that is 39 times of the upper limit minus the lower limit. So the value is 39. Is that clear? So like this we will solve the integrals by taking the innermost integral, solving first and then substituting the limits, making into the single integral and then solving the problem. I hope you could understand. Let us now solve some more problems like this. Now integral of, for example, you have 0 to 1 and integral 0 to 2 xy square dy dx. Now again put the brackets for dy. Now it is understood that the y limits are from 0 to 2. So therefore now it is given as, what can you write now this one as? Integral of 0 to 1. Now look at the value, the function here. Now there is x, there is y square and there is dy. Now the integration we are doing with respect to y. So the foreigner here in this is what? Foreigner means the one which will not suit is x. We are integrating with respect to y. So take down this, just send this x outside of the integration. Now what happens? X comes outside and then integral 0 to 2 y square dy, open close the bracket, dx. Like that you can do. Now that is integral of 0 to 1 x times of integral y square is y cube by 3 within the limits 0 to 2 dx. Okay. And now what that gives you? Integral 0 to 1 x times of, what is the upper limit? 2. So 2 cube by 3 minus the lower limit is 0 dx. So now what is this? 2 cube means 8, right? So 8 by 3 I will take out and integral x dx becomes x square by 2. Now put the limits from 0 to 1. So again it is 8 over 3 to the 6 and the upper limit is 1 square is 1, lower limit is 0. So it cancels, right? 2 4s and 2 3s. So the value of the double integral is 4 over 3. I hope you could understand. Yes. So let us do one more problem like this, which are having both functions now. Let us see the fourth problem now. Suppose integral 1 to 3, integral 0 to 2, you have xy plus 5x square times of dx dy is there. Then how to solve this again? It can be written as, first you have to put the brackets, correct? It is of dx. With respect to x we have to do. So now what is that? Integral 1 to 3. Now you are integrating with respect to x. So let us now split this into the two parts, as because there are two terms, term by term integration. Okay, xy dx plus integral 0 to 2 5x square dx dy. We are splitting the integral. Now what we get here? Integral 1 to 3. Now in this integral, what has to come out? The value y is a foreigner because you are integrating with respect to x. So now y comes out, and then integral 0 to 2 x dx, which is x square by 2 within the limits 0 to 2, plus 5 comes out, integral x square dx will be x cube by 3 within the limits 0 to 2 dy. This is what you can write. And now that gives you integral 1 to 3 y. I can take y by 2 outside. Now upper limit is 2. 2 square minus 0, which is 2 square, plus 5 over, I'll take 3 outside, and upper limit is 2 cube minus 0, that is dy. So what is this now? It is 2 square by 2 becomes 2. Integral y is y square by 2 within the limits 1 to 3. And then it is 2 cube is 8. 8 5s are 40 by 3. And the integral dy is y within the limits 1 to 3. So what it gives you? Now this 2 and this 2 gets cancelled. So it is upper limit, 3 square means 9 minus 1 square is 9 minus 1, plus 40 by 3 times of 3, upper limit is 3, lower limit is 1, so 3 minus 1. Okay, so what is the value of this integral? It is 9 minus 1 is 8 plus 40 into 3, 80 by 3. So the value is 24 plus 80, which is 104 by 3. So this is what the value of the integral. I hope it is clear, all of you. So how we have done, whenever you are integrating with respect to x, inside you have y suppose, then you have to send y outside and do. For example, you are doing with respect to y suppose, x is a foreigner, you send it outside. So like that you have to solve the problems. I'll give you one more problem of 5, that is integral of minus 1 to 1, integral of 0 to 2, 1 minus 6x square y dx dy. So what we do? We just put the brackets here. Okay. And now what we do? This is given by integral minus 1 to 1, integral 1 dx is x, minus, take out a 6y outside of the integration, integral x square dx becomes x cube by 3. Now the limits are from 0 to 2. You can split this and write also anything is the same, 0 to 2 dy. Are you able to understand? And now this gives you integral minus 1 to 1, upper limit is 2, lower limit is 0, 2 minus 0. Now this is cancels that 2 times, so it is minus 2y times of upper limit is 2 cube means 8, lower limit is 0, dy. So what is this value? Integral minus 1 to 1, 2 minus 16y dy. So what is this? 2y minus 16y square over 2. So 2 ones and 2 8s gets cancelled. Now the limits are from minus 1 to 1. Now let us apply the upper limit is 2y means 1 minus lower limit is minus 1. So whenever there is minus, you please be alert. And minus 8 times of y square is 1 square minus minus 1 the whole square. So the value gives you 2 times of 1 plus 1 is 2, and this is 1 minus 1, this is 0. So therefore the value of the double integral is 4. I hope it is clear to all of you. So like that. Now just let us do an even number of problems, that is 6, let us say. Now let us have this problem. Integral of 0 to pi and integral pi to 2 pi. Now sin x plus cosine x plus cosine x times of dy dx. Now here you are integrating with respect to y first, correct? We'll put the bracket with respect to y first. When you integrate with respect to y, then what is this whole thing? It will become, you have to send this to outside because it consists of x terms, okay? So what we do now, it is integral of pi to 2 pi. We will take sin x plus cosine x outside of integration, and integral of dy is y within the limits 0 to pi dx, okay? Now what is this value gives you? Integral pi to 2 pi sin x plus cosine x times of upper limit is pi, lower limit is 0 times of dx. Now how to solve this? This is of the type sin x plus cosine x pi, correct? So just we will use the pi times outside, integral pi to 2 pi. You can split it or you can do the normal way also. Sin x times of sin x dx plus integral pi to 2 pi cosine x dx. You can split like this or you can do normally also, no problem. Now it is pi times of integral sin x is what? It is minus cosine x. Now within the limits are from pi to 2 pi. And then plus integral of cosine x is sin x. The limits of sin x is from pi to 2 pi. So this is what the value. Now what we get here, that is pi times of minus cosine upper limit is 2 pi minus the lower limit is minus cosine pi plus, now this is plus sin upper limit is 2 pi minus sin lower limit is pi. So let us now see what is the values here. Pi times of, all of you know the values of cosine, at least some few values you should know. Sin pi, sin 2 pi, sin 3 pi, sin n pi, in fact all of them are zeros, okay? Whereas cosine pi is minus 1, cosine 2 pi is plus 1. So if you remember this, then it will be easy for you, or otherwise your calculator gives you, you will get the value. So cosine 2 pi is 1, so it is minus 1. Cosine pi is minus 1, so it is minus of minus 1, which is 1, plus sin 2 pi is 0, sin pi is also 0. So the value of this is minus 1 is minus 2 pi is the value of the double integral. I hope it is clear now, I think so. So this is what about the double integration. We have done few problems. Try to understand this and practice properly. Whenever you practice, then only you will get good score in the exam. Thank you so much. Wish you all